So tuples or the tuples are also a collection of heterogeneous data types, right? As similar to the list that is also containing some different type of data types, right? But the only difference is that this is immutable, right? That is, you can't like edit the things. Like once you have added up, you can't delete it. You can't uh, replace it. That's the thing, right? So that is immutable, right? Once you define the things inside the tuple, that is defined, okay? Then you can't just change it up there. So for changing again, you have to convert it in list, and then you can change it up there. And then again, you have to convert in the tuples. That is. So let's just give you an example. So tuples are immutable. Okay. The only difference between a list and a tuple is that tuples are immutable and list are mutable. Okay. All right. So like how to define a tuple? So we defined a list using the square brackets. So tuple will be defined using the round the first brackets. All right. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That is 10. All right. Something else messed up there. Yeah. So all these things and just give it a variable kind of var. That is done, right? So type of var is a tuple. Okay. Now, apart from the you can say editing part, apart from that, if you want to count something, if you want to find the index of something, if you want to go on for iterating of the things, or if you want to go for slicing or ranging of the things like var of 0 to 5 or kind of thing, right? Var of reverse of this. So this can be done, right? This is possible, everything there, right? For indexing, slicing things are pretty good, right? But when you say that var of this is var of 5 and you want to change it as 0, 1, 2, 3, 4, okay, you want to change it as replaced. When you run this, you will get an error. Okay, I'm running it and there is an error that tuple object does not support any item assignment. Cool. So, but still I want to add it there inside a tuple. So what I can do is, okay, that is not a kind actually of a tuple, right? So it is not a method of a tuple. So what we can do is, we can convert this var into a list first. Oh shit, this is list. Okay, and then you can write it as that var of 5 you want to as, okay, just copy this, like cut this and paste it over here. So that is like in list you can do, but not in the tuple. Okay, and then you can make it as a tuple of your var. Cool. We'll run this and the var came. Okay, so this is how you can change. Now, what if I am writing it as v equals to 20? Let's say 20. So is this a tuple? If I see the type of v, no, it is an integer. So to make a tuple with one particular element, what you have to do is you have to give a comma there. Just a comma, that's it. Okay, so that defines that you are going to add some multiple elements inside this first bracket. So that states as a kind of a tuple. Now, if you see the type of v, this will be a tuple. All right, clear? Cool. So this is all about tuple. Okay, guys, you can just, let's say if you're having X for any X companies over there.
Sir, too much voice is coming.
From my side,
Someone mic is on.
from my side, it's coming. Oh, my.
No, sir, now it's clear.
All right, thank you. So let's just say some of the companies.
Sir, what was that thing you did replace? About you did var of 5 equal to replace. So
Okay, this is just a you can say a kind of a value I want to write. It can be 2, 3, 5, anything. I have used just replace so that it can be sensed as that we are replacing something.
Okay, okay, got it. Got it.
Alright. Something problem? Yeah. Microsoft. Okay. So let's say you have a list of not a list, a tuple of company over there, and this is a type if you see of export. So it is tuple, right? Now, if you want to add something there, right, you can't use append, you can't use dot add or any kind of thing. So let's say you are saying in this, you want to add this HP. Not possible. So only a tuple can be added to a tuple. Give a comma and that will be done, right? So no replacement and all things. Now, in a particular variable, let's say a tuple for the names, yeah. So index 3 run, right? Count 3 1. All right. So these are the possible things inside this topic. I hope this is clear to you. Now, like moving up to the sets. Now, sets being okay in the tuple also you have an ordered thing, right? An ordered data output of data as ordered. So the proper definition would be kind of like it is a collection of ordered heterogeneous data types, and it's
Sir, can
immutable.
you please repeat that one? Actually, I didn't understand.
Which one? Which cell?
The this thing which you said now, where dot index. This one, yeah, the last two. Where
Okay,
dot index, where dot count.
cool, no issues. Let's see what is my var. So my var is 1, 2, 3, 4, 5, replace 7 and 8, 9, 10. Now what is the index value of 3? Var dot index of 3. So if I see index, so this is 3. What is the index value? This is 0, this is 1 and this is 2. So index value is 2. Similarly, if I write var dot count of 3, that is how many 3 are there. So there are 1 3. That is only 1. Right? Cool? Understood?
No, but when it is index, so it is number 4, right? I mean, one, 2, 3, 4. Fourth is the
No,
like it should be
it
4,
is
right?
it is searching for where this 3 is. What is the index number of 3? Okay, so
Okay, where? Okay, got it, got it, got it. Okay, where is 3? Okay, okay.
okay, all right. Now sets are something which is an unordered collection of data. Right, this are an unordered collection. Unordered collection, it means right whenever you are writing or defining something inside the sets, it will not remain in the same order. Let's just say this is 1, 2, 3, 4, or let's say this is A, B, C, C, D, E. You define your X, you see your X, and you can see your order. Okay. So it is not like always you'll get something inside a sorted way, right? It is not like such. But the order will not remain the same. So if you see the type of X you have defined as a kind of a set. So here the data, actually the main thing is like here the data are not in an ordered way. And the second important thing is that here you can't write any multiple elements, or you can't have any multiple elements over here. Multiple elements, let's just say that this is your X, like let's see you are having A B C D E, right? And if you define it as a set of Y which is having an elements 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Okay, there is some errors, no issues. Let's say only up this much element, right? So double 1, double 2, double 3, 4, double 5, 6. Cool. Now if you see your Y, there's some syntax, okay, right? So like if I run to see my Y, print while. So this will be 1, 2, 3, 4, 5, 6. Instead of all these things, there should be only 1, 2, 3, 4, 5, 6. This is why, because once you have defined any element inside a set, you can't duplicate, you can't repeat it there. So if you repeat it there, it will not affect the data itself, right? So if you see the length of y, so it's totally the waste of time if you just repeat the data inside a set. That is not a good thing, right? Okay. What is that? It's not ejected from value. Cool, no problem. Okay, so here just you can do a lot of things. Alright, so let's just quickly see what are the things inside this set. So, cool. Set starts with add, clear, copy, difference. We'll see all these things. Okay, there are a lot of fine. So, well, starting with the add. Okay, now let's say you have a list of usernames, right? You have a list of usernames of a Gmail ID. Let's say this is XYZ. Let's say this is ABC, EFG, HIJ, anything, right? So let's say these are the user of Gmail ID properly, right? And there comes one more user, right? There comes one more user. So how to do with that, right? So let's say now we are going to take an input from the user and we'll just split it there with the @ and if the user is not in the user, then we are going to add up the things, right? So for adding up the things, what we can do is we can just write add. So what you want to add is the user. That's it. Done. Right? And print user added. That's it. Run this. Let's just write something cool. So okay, that will be a problem. Let me terminate this one because that is not a correct program. There is some error. If user of 1, sorry, 0, add user of 0. 0. Done. @gmail.com. So just added. Why? Well, we'll see our user. Our user is and also a user. So our user is this ITD and this a list, right? And what about the main user? So here you can see. So what add does, right? As comparison to the list and the tuple, not tuple. So tuple is not having anything. So as compared to list, right? Whenever you add something, you see it in the last, right? But in case of a set, as I said, the data is always an unordered. So you'll be getting any of the things, right? In any place it will be inserted up or right added up kind of. Okay, so you can see it in the second last position. Okay, similarly, now let's just run this again and let's say let's just write it up. So this is added. Cool. Again run this and again you have seen something over there, right? And if it is not there, then for else you can write up. Oops. You can give us. You can give it like. Okay, that's nice. So let's just run this again. So it gave us just a smile over there, and that is how it works. Okay. So in this case, it will remain the same that was previously. Okay. And if it is found, what you can do is you can say the user to be equals to none. this is also you can say. So if this founds there, so I think it will be oops, that is right. And now if you see a user, you'll be having none, right? That is nothing is there. That's nice, right? Because if it is already present aside our main user, so why I'm going to take up that, right? All right. So this is like if you want to add anything, right? You can add it right there. Let's say this is A, and just give some unordered 141 4213. Now, if I say A dot add 5 and I print 5 after add, A. So you can see AFTER. So after adding, the 5 is also there inside this, right? And you could see it to be a nice one, right? Okay. So this is the very first thing, that is it of add. So this add an element to the set and has no effect if the element is already present. If it is already present, no effect. But if it is not present, it will add you there, right? Then there we have clear and copy. Okay, we'll see it, but before that, we'll just see all the removals method, right? So how to remove something from a set. Now, let's just say that you want to remove 2. Okay, so what we'll write, A dot remove 2. So this is after removal 1, 3, 4, and 5. Nice. So this is one of the method of removing something there, right? So you have 3 kind of removal method inside the set. So one is your remove. I think it's R, P, RS. Yeah. So this removes an element from a set, and it must be a member, right? So if it is not a member, this is important. If it is not a member, it will raise a key error, right? And what is a key error? You'll see. Let's say you want to remove 10. So you got a key error. That is 10 is not exactly there inside this remove. But in case of this remove, if I use discard and I'll again print A after discard. Can you see difference after like doing the operation? No, still it is 1, 3, 4, 5, right? Why? Because the discard will remove the element if it is there, right? And if it is not there, it is not going to give you any kind of error. So just see the discard statement. Yeah. So remove an element from a set if it is a member. So if it is not a member, then do nothing, right? Don't give me any kind of errors. So 10 is not a member of this A, and still output has been generated, but no changes and nothing has been done, right? Okay, fine. And now similarly, you are aware of this pop method, right? So if I just say this as pop, and write A after pop, first print A before pop, and then A after pop. I think it's cool, fine, done. Well, run this, and you could see, right, that is before pop and after pop, right? So this is done actually, right? At the pop, what does is it removes the last element, right? Where is the pop? Where is P? I So it removes and return an arbitrary set element. And in this set one, it just removes everything, right? And if the set is empty, you'll get a key error, right? So these are some of the methods used to remove some elements from a set, right? And one more thing is like once everything is done, you can just, this is a very common method to clear up the things, right? So A is an empty set now, right? So you can just clear up the things after making it like that, right?
So can you repeat the pop actually? What did you do before and after pop? What did you confuse?
Sorry, didn't get it.
The pop, yeah. Can you just repeat pop?
Okay, like you didn't understood the method of pop and set, right?
Yeah, I did not understand.
Sure. All right. So pop is like, okay. Let me give you another example. You'll get to understand it more clearly. All right. So, like in the case of list, if I say 1, 2, 3, 4, and pop, 4 would be out, right? Correct. But in the case of a set, it will remove any random number from the set, any random element from the set, you can say, right? So, like if the set is also if the set is updated, or if it is like printed up, right? So if you can see out the difference, if I again run this, pop from an okay, A is an empty set. All right, just 1 minute. Now, if I just again run this, what you can see, 1, 2, 3, 4, and 1 has been removed, right? So mostly what happens, it returns an arbitrary element from a set, right? It just removes any of the random element from a set. It is not compulsory that it will be removing a last element in case of this. Okay, understood. So anything will be just removed from a random state, you can say. Okay.
But on the basis of what? I mean, it removes just random. On the basis of what does it remove?
I didn't get it again. Like on the basis of what you are trying to ask. So
No,
like.
like the
Mhm.
yeah, like POP, like you did before pop, after pop. So, like the number, if it is removed, so how it is getting removed? That I'm not getting.
That actually, see, that is a random state. So random state does not have any particular pattern, I think, right? So random is like it will be removed. Like let's say that if you are writing it as import random, right? Let's say so I'm getting a number, right? And every time I'll be getting a new number. So I could not find any pattern inside this, right? So there is no pattern for a random thing.
Okay. Got it. Okay.
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 All right. Clear. Cool. Now, let's just say that you have some elements, right? This is a set of colors. Oh, sorry. And this is like, no. So this is red, this is yellow, this is green, and let's say 3 of there, right? Now you want to add some colors, you can use add, and like you can write up the things, right? That will be done. But if you want to add now a lot of colors at once, right? So like this in the list we used to do by the append and the extend method. Similarly, here also for adding multiple things, you have a update method. Okay, so you can update with that. So let's say you are writing it as calls dot update. You write 1, 2, 3. Shit. So if you see your calls, it will be like added up the things. Okay. So this is like update method which can be used to add on multiple values. Okay. Now we'll try to see all those things. Right. The left part. What are these there? So I think it's starting from clear has been done. Copy. I think copy has not been done. So we'll start up with the copy and the difference and going will in a sequence, right? So what difference does? It returns the difference of two or more sets as a new set, right? The sum, we say that all the elements that are present in this set but not present on the other. That is a difference exactly. So let's say this is x, right? And let's say this is A, this is B, this is C, and this is Y. Let's say to be C. C, B, E. Okay, so this is X and Y. Now, the very first thing is we'll try to understand what is a common in both the things. What is being common in X and Y? So that is exactly the union. Union of X and Y. Oh, sorry. It's not union, it's intersection, right? So to find the sum of all the elements, that is, if you want to sum up all the elements, that is A, B, C, and C, D, E, you'll be getting A, B, C, D, E all. Okay. So like C will not be printed for 2 times as it is for 1, right? So for seeing the common, that is intersection. Sorry for that, right? So it is intersection. So x dot intersection of y, and that is C is common thing, right? Okay. So C is the common one. Okay, someone came up. Cool. All right. Now you can also write it as x and y. That is an intersection. Now x and y, the union. Okay, I think it's clear, right? So for union you can use this. For intersection you can use that, right? Apart from that, for finding the difference is like x minus y. That's it, very easy. X minus y is the difference. So if I write x minus y, I'll see the difference of the x with respect to y. All right. And if I write y minus x, I'll see the difference in y with respect to x. So got it? Like if I write y minus x, I'll see the difference in the y as compared to the x. And if I write x minus y, I'll see the difference in the x set as compared to the y. Okay, basic mathematics, right? Okay. Now this is basically the difference. If you write it as difference, difference, so difference of y. So that is the same thing. You are getting in x minus y. And the similar, if you write y dot the difference of x and run this, cool. So similar thing for the y minus x. Okay. Now if you say you want to find the intersection update, right? So these things are clear, right? Now going with the update methods of all, right? That is intersection update, difference update, symmetric update, right? So first of all, let's try to understand what is symmetric difference, right? So symmetric difference returns you the symmetric difference of two elements, right? That is all the elements that are exactly one of the sets, right? Okay, we'll try to see. So let's say x dot symmetric underscore difference of y. So A, B, D, E. So that is uncommon things, that is A, B, D, E. C is a common one, right? You see your X, this is your X, this is your Y. What is common? That is C. So, what are the uncommon things? Symmetric difference, right? But in case now, if you use update things, now for whatever you are using, let it be for difference. So, if you use for difference update, whatever the difference would be there, and the rest thing will delete it up, right? So, let's say we are using the intersection update for now. Now, let's say this is my A, which is 1, 2, 3, 4, and this is my B. Let's say it was 3, 4, 5, 6, 7. Okay. Now I'm saying that I'm going to do first. I'll be printing up, right? Okay. So you can see A and B. So I'm doing A dot update all the update methods, right? So I'm doing A dot update of B, and will print this A, and after update. So, well, this is 1, 2, 3, 4, 5, 6, 7, and after update it will be like this, right? In case now, if I am saying A dot intersection, you know what is intersection now. So, using intersection update, that is, you'll be getting the elements after the removal of the intersection, right? So, if I see now A, and if I write it as after intersection update, run this. So 3, 4, 5, 6, 7, right? 3, 4, 5, 6, and 7 after intersection update. So what intersection update does? See that statement where it is it's above. So update a set with the intersection of itself and the another, right? Similarly is for the difference update and all. Alright. So well, let's say A dot, any difference is there, A and B. So what is my A? It's 3, 4, 5, 6, 7. And what is a B? That is also same. So that is a problem. It remains so the same for both the sets. Now again you have to declare it. Let's copy this. Okay. So this is my A for now. And I'll be using now difference update. Well, let's see A, that is 1, 2. What is B? That is 3, 4, 5, 6, 7. So what you can see that from 1, 2, 3, 4, you are only having 1 and 2. So where does the 3, 4 gone, right? That was a common thing. So only the difference is 1 and 2. So it will update. It will just remove the things what are the common one. That will be removed, right? Similarly, it's how symmetric update works, right? Difference I'm saying. So this is symmetric. This is difference update of B. It is A. So that is how it works. Okay. So I think it's very clear to you guys, right? And
Sir,
then you have
sir, please again explain intersection update.
Yes.
Please explain the intersection update.
Okay. Intersection update. All right. Let's say this is X, and this is A, this is B, this is C, this is D. All right. This is Y, and this is D, this is E, this is F, and this is G. Cool. Yeah, right. So common things are D. Let's just say that to be C2, right? So these are the common things. Now what is the intersection of this first X and Y? It is C and D. Now if I'm saying that X dot intersection update of this Y, right? So I want to update the intersection part. I want to update the intersection part in X, right? So if I see my X, it would be C and D. If I see my Y, it will be everything, right? If I say Y dot intersection, update this X, right? So I want to keep only the elements which are common in Y as per the X, nothing else, right? So we'll see my Y, that is Y. Now if you see your X, Y, right, it is only having C, D and C and D, understood? So rest which are uncommon will be deleted up. Got it?
Yes, sir.
Cool, nice. Next we up have disjoint and subset and supersets and all, right? So covering up both those things. Let's say this is your A and this is 1, 2, 3, 4. This is your B.
Sir, I have one question.
Yep. Say.
So the symmetric, the function which you use, symmetric intersection update. So, like, what is the point? Because it is almost same, right? The symmetric one which you used. This one, symmetric difference update. Yeah. So we have the same output, right? Like 1, 2, 3, 4, 5, 6, 7. Like earlier also we got.
Okay.
So how is this function different? I mean.
Cool. No issues. Let's just take an example. Okay. 1, 2, 3. Y is to be 3, 4, 5. All right. So what is X dot symmetric difference of Y? 1, 2, 4, 5. Okay. Right. So X is 1, 2, 3. Y is 3, 4, 5. The elements still remain the same, whatever in the X and Y it is. Okay. But the same if I just copy for now. Paste. Update. What is X? 1, 2, 4, 5. What is Y? 3, 4, 5. So now your value of X changed. Whatever the exact value was coming before, while writing this statement, now your X will be totally changed. In place of 1, 2, 3, every time it will be coming as 1, 2, 4, 5. Got it?
Okay.
Right? So that will update the symmetric difference in that particular set what you are using it. Take the first one, whatever you are. Okay. Yep. So where was I? In ABC, I think. Yep. So ABC is like having some characters 1, 2, 3, 1, 2, 3, 4, and 3, 4, 3, 4 is there something. Yeah. So 1, 2, 3, 4, 3, 4, and 4, 5 in A, B, and C. Okay. This again lies me up there A, B, and C. That is 1, 2, 3, 4, 3, 4, and 4, 5. Now, what is disjoint? Right? Just first see the statements. Well, so we'll see all of the statements at once, right? So, what is this is disjoint? So, disjoint returns true if two sets have a null intersection. That is zero uncommon elements, right? So, if you don't have any uncommon, if you don't have any common elements, then it is disjoint. If you have a common element, then it is not a disjoint one, right? What is a subset? So it report whether another set contains that particular set or not, right? Let's just say that we'll be doing with the examples. Okay. What is superset? So it reports whether the set contains another set or not, right? So okay, that is very clear with the examples. So let's just take examples. So we are having A, B, and C. If I say that if A, this A is disjoint, is disjoint? Yep, correct. Of B. So this is false. Why? Is there any element in the A which is also in the B? 1, 2, 3, 4. Yeah, 3, 4 is there in the B. Right. So is there any element with respect to C? Still it's there, same, right? So what to do? Let's just say A dot remove 4, otherwise we will be getting everything as same. All right, now with respect to B, Okay, just let's run this again. So we are having 1, 2, 3, 3, 4, and 4, 5. So with respect to B, it's again false, but with respect to C, it will be true. Why? Because uh, in the A or in the B, in the C, there is no such common element. So S disjoint will be true. I think you got it right. Now for this subset. So A is a subset of B. That is false. But if I say B is subset of A, that is still false, right? So let's just take anything, right? There we can write up. Right. So Y is having 1, 2, 3, 4, 5, and like A is having 1, 2, 3. Now if I say A is a subset of Y, that is true. That is, every element of A is present in Y, or every element of Y is present in the A, right? But in case if I write Y is superset of this A, that is true. So whatever the values or whatever the elements are there in the Y is also present in the X, right? Got it? That is a superset, that is a subset, and this is how I think, let me just see it. Yes, this is how we end the sets. Clear. Any questions you guys have got there for set? So for finding the size of a set, you can use s dot dash dash size of this, and that can be used. Find it there. Things. So s is not defined. You can take it for anything x and y. So this is the size of your set. There comes a lot of method when you just see the documentation of the things, right? So you can find a lot of things over there. Of anything more left? Copy is being left. So copy is like the same thing again. Just say this is AZ and you want to do x dot copy. Say AZ. The only thing is that this is a wrong thing, right? No indexing. Okay, that is only not possible. Otherwise, else everything is like very good in the set. Okay. I hope this is clear to you, right? Set are very important thing, right? It can be used in various sectors and various methods. Stop this.